Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good. Last session we did try to fix the mess of the C-casts between the different matrices. And it broke the game, so that needs some more investigation before we continue with that. Let's see what we can review. Let's see. Review approved. What is currently approved? This one and this one and this one. Detected mines. Yeah, let's look at this first. Needs to be replicated in generals. Okay, cool. Okay. Looks simple enough. Okay, cool. Then let's merge this guy. Okay, confirm squash and merge. Okay, fantastic. Tweak drawable, set correct model tint color after loading a save game. Replicate in generals. Okay, cool. Let's take a look at it. Files change to because loading its value is unnecessary and undesirable. 5.6. Mm-hmm. 5.6 version smaller equal 5. Blah blah. Trigger tinting after loading a save game. Blah blah. 0. Okay. Yeah. Okay, this looks plausible to me. Okay. Then we can set correct model tint color. Tint color after loading a save game. Okay, cool. Then we merge also this guy. Okay, I think this one was resolved. Okay. Okay, cool. Move or swap. Okay, cool. So how do we title this? AI update. do perf AI avoid a few avoid a few STD vector copies when passing path and passing AI path to functions. Yeah, I think that works. Path. Avoid a few STD vector copies when passing AI path to functions. Okay. Okay. Then set that to approved again. Okay. Let me take a look at this guy again. The same condition exists in update internal. Does that need similar treatment? Assuming the state is dependent on a moving target, I cannot imagine any cases where it makes sense to pursue an undetected moving target, let alone a moving minefield. Okay. If the damage type is damage disarmed, do we even need to test for the target kind of? We assume that all object kinds can be approached if they can be disarmed? No. I intended to prioritize consistency by following the same conditional patterns used in weapon.cpp. Okay, fair enough. Can you perhaps we can open an issue report for looking into simplifying these conditions later. reserved. Status cannot apply for the entire duration. That means if combat drop is in progress, then this guy will wait until combat drop is complete. Correct. Okay. Okay. Object is in the process of preparing or firing a special ability. AI REPL into. The REPL status cannot apply for the entire duration. The status cannot apply for the entire duration of the REPLing, nor can we test for active REPL status. If we test for REPL status to determine freedom to exit, then the units won't be considered free to exit when doing the actual REPL. The units must be free to exit when it comes to the instant they are ready to REPL, which is why the status is cleared as soon as they are ready. Let's see. So retake compatible is dependent on this status. It's using ability. Clear. If not, retake compatible CSC. Way to exit. Get AI free to exit. The status cannot apply for the entire duration. Nor can we test for active REPL status. Doing action REPL. Retail comparable CLC. Set a state that makes get AI free to exit pass in the call below. Because the state is described. Status cannot apply for the entire duration of the rappelling, nor can we test for active REPL status. If we test for REPL status to determine freedom to exit, then the units won't be considered free to exit when doing the actual REPL. Units must be free to exit when it comes to the instant they are ready to REPL. Let's see. Okay, then maybe. So we have AI REPL into. Exit object via door. Reserve door for exit. Specific rider free to exit. AI REPL into. Private REPL into. AI REPL into. REPL states. Updates. Can enter objects. Exit object via door. Enter. So I wonder if there is a way to say, hey, we are rappelling now, and then check reserve door a different way or so. I mean, that's what it's doing here by setting the status here. But maybe it should be a function argument instead. I still don't fully understand, where does the rappeler check for an exit door? Where's that happening? Do we know? Let me search for this call. Writer change contain, no. Chinook update, yeah. So there's only this one call here. Rappeler exit door. Reserve door for exit. Get AI free to exit. Let's search for that. Get AI free to. How about we put a breakpoint in here, and we stash our current changes. We compile, and we test it real quick. While we wait for the compilation, let's see what else we have here. Good, let's run this. Now let's do a REPL. So, yeah, I think DEFCON 6 is fine. Then we built a Chinook and a barracks and some ranges. Let's get 4 more. Okay, let me put them in there. Okay. And then we put a breakpoint here. And then we REPL in here. Okay, so now it's being called from, from here. Okay. Free to exit. Okay. Set status is using ability. It's using ability. Combat drop. If not, it's using ability. Okay, I see. Okay, then how about reserved door for exit? This is a pure virtual function. Okay. Same. Okay. So basically, he just sets this flag so that this function here, or this other function, this one, behaves in a different way than if this was called if we clicked on the icon, right? So if we now remove this and then let me reduce surrender FPS to 30. So we REPL into this and then we drop these guys. Yeah. They're all. What's going on with the shadow there? What is this? What? Okay, that looks wild. Huh? Where did the rangers go? Oh, they are here in the sky. What? How did that happen? What the hell? My gosh, this game. So buggy. Let's do it again. So they have to somehow exit at the same time and then they get stuck. Let's try it again. Oh, there we go. Yeah. There they stand in the heavens. Can they shoot actually from here? Let me see. Let's shoot here on the ground. Oh yeah. Look. Man. What is this? That's wild. Can these rangers actually attack these? Oh, they can. Okay, that's wild. Can tanks also shoot at these? Let's see. No, I can't, because it's in the heavens. Interesting, but the rangers can attack it. What about Avenger? Can the Avenger attack it? I mean, it's flying, right? Oh, it will laser it. Okay, okay. What about... What about Comanche helicopter? Will that attack it? In the name of science. Yeah. Okay, so the Comanche is about the same height. Yeah, let's see if we can attack it. Oh, you can. Look at that. Yeah. Okay, cool. Oh, I'm very injured. Let's go here. Okay, anyway, so yeah, it's not great because it's adding to the spaghetti this year. Yeah. It's dependent on the status. Yeah. Repeller, get template. This kind of can repel. Get AI free to exit. It's using ability. Status. Doing combat drop. Exeter is kind of can repair. Potential repeller. What is this function? Okay. Okay. Doing combat drop. Free to exits. I think you can do. I think we can do if retail compatible CLC, then do this. Else, Jesus, else hello, and if apply doing combat drop and exit test status. Object status is doing repel, is initiating object status. Object status. Immobile disguise. Is initiating repair. Return free to exit. Kind of can repel else. Test status. I think this would be a bit clearer to understand. So this one is the old behavior. And this is the new behavior where it will only be free to exit here during the combat drop if it is initiating repel, but then, yeah, and then it will go down here into this way to exit. This will make it a bit clearer. New status to make reference specifically for this. The way maybe would be to say using affinity. Well, I still don't understand why the other thing wouldn't work though. This AI REPL into, why would this not work? Status cannot apply for the entire duration of the REPLing, nor can we test for active REPL status. If we test for REPL status, determine freedom of exit, then the units won't be considered free to exit when doing the actual REPL. The units must be free to exit when it comes to the instant they are ready to REPL. Maybe we can do status start REPL or begin REPL. So when it's beginning to REPL, then it's free to exit. Otherwise, it's not yet. It's not doing combat drop. Doing combat drop. It's doing combat drop. Chinook landed. Chinook doing combat. Deployed, right. Yeah, it would be great if we could already use an existing state or something that's, yeah. Make logic easier to understand and potentially avoid troubles if rangers could use some modded ability in the Chinook. changes, we're able to use some modded ability. Begin repair. Okay. Yeah, I think I can live with that. Yeah. Repeller. Clear status. Repeller is not free to exit. Yeah. Yeah, I don't have a better idea here. It would be good if we could get this information in a different way, which there probably is. Like we have this information that it wants to do that, well, but that's afterwards. We have this here, push back. Yeah. Yeah, I don't have a better idea. Then let's do that. Humans must be free to exit when it comes to the instant they are ready to repel. Must be free to exit. a bit strange that here's a debug crash. So it doesn't expect for this to fail. Door non-available. Door 1. Reserved door for exits. So this test seems to be more like a formality, right? Exits. Reserved door for exits. Door 1. Exit object via door. Exit object via door. So this makes sense to me. I'll mark this as resolved. Then let me also say alternatively, perhaps TPP this can be changed to exit interface, exit door, and then exit interface can be changed to CPP if exit interface reserved door for exit. Exit object. Can we change to so if this, then Here we say door 1. Interface, exit object via door. Because call to reserve door for exit appears to be a formality only. The debug crash implies that this is expected to always return door 1. The debug crash this and the other one here, and apply that this is expected to always return door 1. This appears to be a formality only. Data imply that this is expected to always return door 1. Yeah. Exit object via door. Exit door, remove from contain. Exit object via door. Exit object via door. Comet drop. Comet drop. AI free to exit. This way, all the repair related tests in exit can be removed. Well, not true. Nothing should. Well, yes, because then only things are free to exit when it has landed. Yeah. Yeah, this might be an option. Just remove this test here. Reserve door for exit. Just get them out of the door. Yeah. And then we don't need the repel checks in this function anymore. This may be the simplest implementation for it. Yeah, let's have a look at that. Submit review. There we go. When building this logic, it's always good to try to find like the simplest implementation, because the more code you add, the more conditions you add to the code, the more complex it becomes to maintain, and the more error prone it becomes in the long run. And so if there are ways to simplify the logic and still have it function correct, then this is always desirable. And that's why I spent that extra time to like study this code to see if there's any opportunity to make it simpler or more logically understandable, right? Because right now the implementation, it works and we can see it, yeah, it makes sense, but it adds more layers of complexity, right? And so if we can simplify this, then that would be great. Yeah. Reserve door for exits. I mean, this one really doesn't do anything, right? Reserve door for exit, transport. It just checks if it's free to exit, that's it. Free to exit. True. Yeah. Okay. What about this here? Rerun. failed jobs. Still fails. Fails with okay, I will just merge it anyway. How about that? Info page for crash dumps. Good. We spent 1 hour now with reviews. Let's get back to our code. So let's do a exit. Stash pop. Good. So currently everything is broken with the changes we did here to the matrix. So we need to figure out what exactly we did wrong. I suspect it's the inverse functions that we touched. So I would say we take this. Matrix inverse. Then we do here if 0, else, and if okay, that doesn't work. Then here we do m blah blah, okay, and then return m. No, it's const. Oh, return out. Return out. Okay, so this should be the legacy behavior. And then we do the same in Matrix 3D. Yeah. Why is this so huge? Jesus. So inverse. Get inverse. Get inverse. So if 0 else and if, and then we take this. Out. Then here we put M. Then here we remove this. No. Inf. Then here we do out row. Okay. This is correct. Maybe. And then return out. Get inverse. Blah. Inf. Oh boy. Infer, okay. I think that looks about right. What I did before. Yeah. Good. Let's see if that screws up. Yeah. Oh boy. Oh boy. Okay, so I think we did some mistake here. I'm not sure, but the graphics indicate so. Yeah. We did some major mistake. Okay, where did we do the mistake? Let's see. Let's remove this garbage here. There, okay. Good. So we did some mistakes somewhere. The question is where. Uh-oh. Well. Matrix. Well, it's not clear to me. Get transform. Get DX. Okay, it's DX8 transform. No. Matrix inverse. It's the water that looks broken, right? Let's look at it again. It's the water that looks broken and the terrain. The camera itself looks okay. So the water is bad. The ship we can't see. We can't see the objects, but we can see particles. Yeah, it looks fucked. It looks bad. Okay, what did we miss here? Something fundamental we missed. Set DX8 transform. Matrix inverse. So we get a transform. So previously it also got the DX8 transform, and it was just stored in the Matrix4x4, right? But it's fundamentally they would carry the same data. And then we would have an inverse. Inverse. Why does it do an inverse there? Matrix3D. Get transform. Okay, I'm not sure what we missed here. Something fundamental. Something fundamental. DX8 wrapper. Volumetric shadow. Inverse. Huh. What did we miss here? Inverse. Inverse scale. DX8 transform. Render trace. What did we do wrong here? Something fundamentally we have missed here. Like some transpose missing or so, right? Yeah, I think that's a likely candidate, that we're missing a transpose somewhere. Or that we didn't remove a transpose somewhere. That could also be. Dot transpose. Water. Transpose. Aha. W3D always does transpose all on all of matrix sets. Slow. Better to hack view matrix. Set transform. Yeah, word. Let me go to Matrix3D. Wow, that's illegal, isn't it? D3D Matrix. I think there's an error here. Zero, 0, 3, 3, 3, 2, 3. It doesn't. Let me go to here, Matt. So it has row 3. So 0, 1, 2. 0, 1, 2. Operator, row I. Yeah. So this one is illegal here. I suspect that this needs to be. I suspect that this needs to be 0, 0, 0, and 1. I think. Yeah. Yeah. And then here we can do D3D matrix. DXM equals, let's say DXM worlds, M worlds to D3D matrix. Jesus, I can't write. Matrix. There we go. Better to hack your matrix to do slow. Better to hack. think we can do it directly. Take this guy. Mesh X form. Like this. Replace this with mesh transform. Emeralds. And here we can also do okay. That should do. Okay, let's see if that fixes any of our problems or not. Okay, that looks certainly much better, but the shadow still looks wrong here on the boats. Yeah, the shadows look bad. Okay, but it's already looking better. We can see the world at least. Yeah, but yeah, the shadows are oof. Oh boy. They are out of control. Oh boy. Okay, but that narrows the error now. So that is maybe this volumetric shadow. Well, we just touched that. Volumetric shadow. Maybe it's this inverse here. Let me go down here. Let me remove this and put this back in, just to make sure it's not this guy. It seems to be that. Yeah, now the shadows look normal. Okay, so that's interesting. Okay, let's take a look at it. What did we do wrong here? So this guy is a matrix 4x4. This is a destination matrix, inverse, object to world, world to object, inverse. What do we do here? We have this. We set prints. Inverse does not work. Re-implement. Okay. It was never. Okay, it was never used before. Okay. Then what we do now is let's compile in this guy. Yeah. And let's see if that works or not. Okay. So we remove this guy here. And then we see if our new matrix 4x4 inverse actually works or not. It probably won't, because we have already seen that there are some mismatches. Let's see. Okay, actually looks promising. Shadows, 3D shadows are there. They look plausible. Yeah. Okay. Yeah. Okay, looks okay, I would say. That's surprising. Okay. So that's all this garbage here. Yeah. This does not work. Re-implement. Okay, then let's see about the other one. Inverse. This one. Okay, let's compile this one in. Translation. inverse. Where is this called currently? Update the inverse camera matrix. Mesh. Ray collision test class. Cast array. H3. So there should be some bugs if this inverse function does not work correctly, right? Because camera, mesh, and H3 are using this. At least a few things. Yeah. Oof. Looks black. Okay, well, that's not good. Okay, at least we know where to look now. Well, that's not good. Row. Maybe Matrix 3D is actually row major and Matrix4x4 is column major? Could that be? Let me find some information here if it says anything. Column vectors. I use column vectors. So this is column major. These matrices are orthogonal. This class is really a 4x4. Is it? I thought it's a 3x4. Last row is assumed to always be 0, 0, 1. However, since I don't store the last row, you can't do something that you can do with a real 4x4. I use column vectors, so normally transformations are post-multiplied and camera transformations should be pre-multiplied. The methods of this class called translate, rotate x, or perform post-multiplication with the current matrix. These methods translate also have been hand-coded to only perform the necessary arithmetic. The multiplication operator can be used for general purpose matrix multiplication or to transform a vector by a matrix. Some operations in the class assume that the matrix is orthogonal. Yeah. So this is a column major. It's weird that it's a column major matrix, but then they say here row. Like, why is this not called column? Why is this called row? Can't spell matrix here. Oh, okay, then, so this doesn't work, this function. Let's get back to our friend's chat. Let's inquire with him why he broke this. Yeah. The both Matrix4x4 and Matrix3D are documented as being column major matrices. The following function does not yield correct results. Why? I'll take this and then this. This is a very good question, and the short answer is your matrix is column major, but your math is mixing row major, educate, I don't even know what that word means, educate logic with column major, affine translation logic. That's why the linear x3 part mostly looks right, but the translation blow up. Let's pin this down. Column major is not column vector math. That's a key misconception. There are three independent choices. When we lay out row major, column major, vector convention, row vectors, column vectors. Well, it says, let me see. Column vectors. Column vectors. Aha. Okay. Okay. Okay, actually, it does document as being column vector. Column vector. As being column vector. Does document as being column vector. Great. Your matrices are column major and column vector. The bug is not in the translation side anymore. The bug is how the educate is written back. Your inverse code is almost correct, but it's silently producing A minus T instead of A minus 1. A minus transpose, I guess. For column vector affine matrix. Your translation math is correct. Your determinant math is correct. Your educate placement is transposed. Where the mistake actually is, you compute cofactors correctly, but then you're right. Well, you generated this code. I didn't do that. That stores the cofactor matrix, not the educate. Critical rule. The fuck is that? You forgot to transpose. Why this breaks translation? You're computing A minus T dot T. Sometimes looks close or very wrong. Exactly what you're saying. The correct fix. Show me. Store the educate transpose. Where? Replace a right back with this. Where's this? Oh, this one here. This one? Let's see. But it looks the same, doesn't it? 0, 0. Ah, okay. This one is different here. Okay, transpose. Okay, let's try that. Then I will comment out this one here. Translation code stays exactly as you wrote it. Okay. Okay, let's try that. I have no idea if that makes sense or not, but let's see. Okay. Let's pray to the chat GPT God that this works. Yeah. Well, doesn't look like so. Okay. Cool. Let's load some level. Yeah. Well, unfortunately, we only see black. Good, so it still doesn't work. Okay, let's put back this comparison here. This Mat4, is it already I thought say we do Mat4 inf. Then we transpose it. Inf. Let's say we do a Mat4 inverse. That doesn't work. inf get inverse mat4. I need to put this up here. To transpose. Then matrix inverse, and then we transpose again. Match false. Oh. Well, that looks wrong here. Okay, this one looks uninitialized here. R, row, column. Get inverse. So what certainly is suspicious is that here we just take the matrix as is and you do this here, get matrix inverse without questioning the I find this extremely confusing here. Why did this originally work at all then? Like it's using the DirectX function to do get the inverse, but that one has a different matrix layout. So how was this working in the first place? I don't understand. It's extremely weird. This game runs on weird things. Okay, so somehow I guess this inverse now fails because maybe we transposed it here. Let me retry this. That's weird. Still fails. It's always 0. Okay, can we get a valid matrix here maybe? Well, this looks reasonable. But it still looks bad here. Okay, but now we get something. Okay. Okay, that looks valid. Then let me get back the transpose here. Okay, blah blah. Okay, let's take a look at these guys. Oh. Ah, it didn't write it right yet. Match false. Yeah, so this one says 490 and this minus 657. So clearly these are not the same. This also not. Yeah, so there are differences here. Transpose inverse. Get inverse. Okay, then let's do not a transpose for these guys. Let's do it like this. Okay. Match false. Okay, it still is awfully wrong. Let's put this back to what this was previously. Match. Good. So let's take a look at these guys. Okay, still difference. Yeah. Yeah. Okay, originally Matrix3D you simply used D3DMATRIX for its inverse without any transform. Was this correct? The visuals with it looked fine. Without any, not transform, transpose. Transpose. Yes, that absolutely could have been correct. And the fact that the visuals looked fine is a very strong signal that it was correct. Yeah, well. Why no transpose can be correct? Does pure mathematical inversion. It does not care about row major versus column major. It only assumes that the caller is consistent. If your engine stores matrices in column major, multiplies column vector, stores translation, parse the matrix as is, then D3DX is already operating in the same algebraic space. No transpose is needed. Your replacement function looked equivalent, but you compete the cofactor. You forgot the. Okay. Okay, then. Okay, then can you write me a function with, write me a function that does the exact same as this. But for 3x4. But for 3x4 matrix. X4 matrix where the last row slash column is 0, 0, 0, 1. How does it describe here? The last row is assumed to always be the last row 0, 0, 1. Let's see if we can do that. Yes, below is the correct equivalent implementation for 3x4 affine matrix with an implicit last row, assuming blah, blah, blah. Okay, give me that. Correct implementation. Give me. Don't bullshit me now. It looks very familiar to what we already have. Probably bullshitting me. This looks very much like what we already have here, doesn't it? Row 0. Well, this one is different here at the top. Okay, there are some differences. Okay, let's comment out all this stuff here. Okay, then let's see if that would match now with a D3DX matrix or not. Okay, match false. Well, thank you. Okay, it still mismatches. Still wrong. Takes a mat 4. So So that doesn't work. Let's see how it looks visually. Oh, but it does look like something. Okay, so it mismatches with the DirectX matrix, but we see things. Now, what does that mean? Oh boy. Match false. It always mismatches. Yeah. And quite significantly as well. I mean, these values are not the same at all here. How does this work? With some values match, but it's grossly different. So inf I don't understand. So the inverse does not match the DirectX. The inverse results does not match at all, but the visuals still look okay. How is this possible? Probably comes up with some bullshit. Reasons. Classic, extremely subtle engine situation. Yeah, of course. Visuals still look correct. Is the biggest clue. Tell me. Your inverse is mathematically different from this, but functionally equivalent for how your engine uses. What? Inverts a full 4x4. Computes the inverse. But your engine never uses row 3, column 3 outside of translation. So differences there don't matter. Yeah, but there are differences all across. Your engine never multiplies by the inverse the same way. But they look so much different. Like, yeah, this component is the same, but this one is already different. This one is different. Like 80% of the things here are different. Yeah. Like how is this working? It makes no sense. It doesn't. very strange. 0, 1, 2. Transpose. Zero, 1, 2, 3. Let's see if this guy is doing the correct thing or not. So here we have object to world, yeah. Object to world 2. It's to Matrix4x4, object to world 2. Let's see about this one here. Let's put a breakpoint here. I would like to see how different or identical are these guys here. Good. Okay, so watch. So we have this guy and this guy. Okay, this one looks very similar. Just a few rounding differences here. But this looks very similar. Okay, so that is promising. This one looks good. Okay, that's nice. At least this one looks fairly well. Let me say here It looks the resulting matrices. The resulting matrices look widely different. But I can confirm that the other inverse, that the matrix 4x4 inverse matches the results of D3DX matrix inverse can we apply the same principles for matrix 3D? Writing matrices from matrix 3D get inverse and D3DX matrix inverse. Look, why did I? Okay, now I pass this here. Just what's the last row? 3D. Let's see what he says. Yes, this is exactly the right way. Yeah, of course. You've just uncovered the real reason. Matrix works because it is literally the same algebra and indexing that matrix inverse uses. Matrix failed because it did not follow the same indexing model. Let's lock this down cleanly. Look at how inverse reads a matrix. This tells us exactly how the matrix is interpreted. Row stores column J, row I. The matrix is column major and column vector, identical to D3DX. Huh? I thought that DirectX is row major and row vector. What? What is going on here? Internally, your matrix is algebraically this is exactly the same layout. That's why I think this is all bogus. Okay, but let's go with it. Matrix inverse matches, matrix inverse, which has always worked. Transpose were never needed, but transposes are needed. My gosh. Your earlier 3x4 inverse attempts did not use the same indexing convention. They assumed exactly like your 4x4 inverse does. The correct way to do 3x4 inverse, the right approach, take the 4x4 inverse logic you trust and specialize it, assuming the last row. Tell me. Okay, I'm gonna just copy this garbage here. Let's see. So I would take this and overwrite this. Yeah. Okay. Last row is implicit. Same minus. Blah blah. 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 Always 0. Okay. Translation. Okay. Well. Out row. Let's do that. Good. Let's see if that matches or not. I'll put a breakpoint on here. I think if we just get it to match with what DirectX did, then at least we don't break anything, because that's what it currently uses, called DirectX matrix. Whether it's really correct or not, I have no idea. But as long as our result matches exactly what the DirectX matrix does, then at least we're not changing behavior, right? So let's see. Match false. Okay, that's already a great start, but I think that's the first two. They just come in with invalid data, I think. Okay, let's see what we get now. Match false. Okay, let's take a look at them. Yeah, you better match now. Yeah. Well, I can already tell that they don't match. Okay, but okay, how about we do the following? Just for tests. We comment out this shit, yeah. And we do a, out of the matrix, we construct a matrix 4x4, M4, M, yeah. And then we do a matrix 4x4 inverse. And there we pass matrix 4x4, M4 inf. Yeah, then we pass this, then that out, and then M4. Okay, and then we copy Matrix3D out equals Matrix3D M4. Can we do that? We can't. We need to do this here, I guess. Out. And then we do M4. M4. Let's also do here the row. Great. M4 inf. There you go. Okay, so now it would go through the matrix 4x4 inverse. Is this private? Protected. Okay, well then we need to remove this. Okay, let's do that. Let's see if that would give the correct behavior. Must return a value, of course. Turn out. Return now. Say if this equals null, then return null. Good. Let's see if that will work or not. Man, this is so fiddly here. So, match false. Match true. Okay, that matches now. Look at that. Okay, so somehow ChatGPT cannot write a correct inverse for a 3x4 matrix. It cannot do it. Yeah. Well, okay, that was simple. One. Okay, let's try some other ones. True. Okay. So remove this here. Match true. Let's put her here, breakpoint. Okay, but it's still black. Because we return this one. Why is it black? Okay, that's unexpected. Inf2. Okay, I don't know why. Update the inverse camera matrix. So we only get matches, but somehow it's still broken. Why? Is there something wrong in our comparison here? I mean, it looks strange that they always look the same. They always look like identity matrices, right? 1, 1, 1. Looks like identity. Um, hmm. Okay, I'm not sure what the error is now. Let's see what we have here. First we have okay, let's take a look at the new bypass door reservation, as repellers are always expected to be free to exit. This avoids prior rappel conditions in Get AI free to exit from allowing repellers to be freely dropped from the Chinook during this state. Bypass. That makes sense. Flight status, Chinook landed. Okay, this makes sense to me. It's much simplified if this code is removed later on. Okay, cool. Looking good. Okay, mark this as resolved. Can also mark this as resolved. Okay, cool. Okay, I still don't understand why we now have a matching inverse, but when we look at the visuals, everything looks wrong. I don't understand what's going on here. Why is it always an identity matrix? That I also don't understand. So we get some value here, inverse, get inverse, update frustum, cam mat, camera inverse transform, get inverse transform. Oh, did we maybe make a mistake here? Camera.cpp. No, we didn't touch it. No. Camera CPP, no. So transform, get inverse. Oh, I think I know what the problem is. This is a problem. Yeah, that's stupid. I don't know why I did this mistake. Let's try this again. That was stupid. Okay, so inf row blah 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 blah. Okay, so this looks completely different. Get inverse. What is wrong here? M M4 M out M inverse Mm-hmm. 0.6, okay. Okay, why? Oh. We are passing a null pointer in there. Oh boy. My gosh. Oh man. That's outrageous. So it was always identity matrix, essentially. Okay, so now this looks correct, and we get here some values. Yeah, okay, cool. Get inverse, and then we have this guy, and then we copy, and it's a match true. Let's take a look. Watch. Blah, 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 blah. Blah, blah, blah. Yeah, okay, so these match now. Cool. Then, so we have now a clear reference implementation. This one works. Yeah, this guy here. Let me put a comment here. This works. Yeah, this works. Good. Then we make here a 0. Then we put here an elif 1. So then let's do the last thing that chat has given us and test it again. Yeah. Let's make it a bit more beautiful down here. Yeah. So let's see what this gives us. So, get inverse. Let's see what we have. Match, false. Okay, well, these are the first two, right? First two. Let's ignore the first two. Match false. Okay. Let's take a look. Row, row, blah, blah, blah. Okay, they look very different again. This one looks the same, but this one is different. This one is also different, this Y component here. Yeah, so this is not quite right. And visually it also looks wrong, yeah. Okay, so let me tell. It is still not correct. The visuals are wrong, and the matrix does not match what this would return, this would produce. Somehow AI has a big trouble with this 3x4 matrix. It can't figure it out. The confusion is not accidental. It's malicious, yeah? It's malicious. Use a different indexing model. If you want bitwise equivalence results, you must run the same math. This is not wasteful, it is correct by construction. Yeah, okay, but that's what we're doing. That's what I've been doing now. It works, but I don't want to do this. Everything else didn't. Use identical math. Uses identical indexing. Bit equivalence. Visuals match. No transpose games. No algebra drift. What the hell is that? No shortcuts. Guarantees correctness. Unless you literally copy source. Final reliable. Yeah, we can do that, but it would be cool if we could do it without that. Critical mistake everyone makes. Here's the uncomfortable truth. You cannot safely simplify a 4x4 inverse into a handwritten 3x4 inverse unless you preserve the full 4x4. Why? Does not do a special affine inverse. Computes a general 4x4 inverse, even when the last row is 00001. And intermediate terms do influence translation. Your 4x3 attempts assumed inverse. That is mathematically valid, but it's not what computes. Looks right, but does not match and breaks visually. Inverse reads the matrix exactly, computes full, produces bit for bit identical results. This is why it is trustworthy. Any attempts to derive the math differently is gambling. What is this wording here? Gambling. The only correct way to implement get inverse. Embed invert extract. Anything else is not equivalent. Coding using works correctly, but is there really no correct way to do it without? Yeah, I find it a bit. I think it's bad if Matrix3D requires a Matrix4x4 to work. It shouldn't be like that. It needs it for nothing else. So can we implement Matrix3D get inverse to work exactly? It works exactly like Matrix4x4, but not use it. But not call this. Yeah, just write me the function the same way. Honest answer, yes, it is possible, but it behaves exactly, so it behaves exactly without calling it, but only if you literally specialize the same. Yeah, it's fine. Not an affine inverse. All previous failures happened because the code stopped being the same algorithm. Below is the correct way to do it, plus why this is the only safe way. The non-negotiable rule. Your working inverse is structurally identical to that. That function computes full 4x4 cofactors, blah, blah. Your 3x4 inverse must execute the same cofactor math. Yes. Anything else will diverge. Yes. Specialize the 4x4 inverse, correct approach. We take your exact inverse code and inline it, yes. Replace the last row, yes. Remove terms that multiply by 0, whatever. Keep the indexing unchanged, yes. Do it. Do it. Give me. Okay, let's copy this bullshit. Okay, let's copy it over here. Yeah. Exactly. Equals 0, he says. Okay. Equals 0. Because it's 0 here. But if it's 0, then why don't we just set it to 0 here? Okay, let's first see if it works. Okay, that's more what I expected, yeah. Have it work exactly the same way, please. Let's do here return null, please. Okay, this looks very promising. Yeah, okay, that's looking nice. So let me put a breakpoint here. So it says that this is 0, yeah? It is. Minus 0. Yeah, because this one is 0. Yes. Okay, but then if this is 0, okay, then can't we just drop these things? Yeah. M3, M1. Yeah. Why this feels overkill? Because mathematically, a Fiend inversion is simpler, but engines don't care about elegance; they care about consistency. Always do full inverse. Your engine was built around that choice. Let me say. The last code proposal works. Can we optimize out all the zero multiplications, or the 0 and 1 multiplications? Safely and without changing results. Although the compiler maybe does it anyway, right? Or with the compiler, optimize 0 and 1 multiplication anyway, and we need to not worry about it. That's my guess, that we just don't care about it. Yes, any half decent compiler will already optimize those away, so you generally do not need to worry about it. But there are a few important DX8 legacy caveats. What modern compilers do for code like this: optimizing compilers, remove, plus, times, fold constants, dead code, eliminate unused intermediates, generate assembly for your unoptimized version. The hand optimized version will typically be identical. What about much weaker optimizer? Doesn't fully eliminate. Let the compiler do the rest. Okay, I may copy this thing here. Let's say here elif 0. This works. It looks much uglier. S3. 0. S4 0. S2 0. S2. Okay, let's see how it works for starters. S3. Okay, let's see. Put a breakpoint here. Match false. Well, that's not good. Not a good start. Okay, well, it looks close. Maybe the epsilon is Not large enough. Let's see what this fails on. R0, 3. 0, 3. Ah. 0, 3. This guy, yeah? Because it's so small. But it should be fine. Ah, it's this one. The epsilon is too... I see. The epsilon is too small. Let's do a... like this. Okay, let's put a breakpoint. We have. Okay, cool. Okay, so that matches now. Fantastic. Yeah, we could do that. Column vector convention. Subdeterminants. Okay, cool. Maybe we can write this a bit nicer here, like so. Last row implicitly is 0, 0, 0, 1. Last row is assumed 0, 0, 0, 1. Okay. Yeah, then we can do that. Okay, cool. Then we have that figured out. Took quite a bit of effort. I do like this one here because it's closer to the 4x4. And the compiler would probably optimize these things here. But... yeah. Yeah, this would run better in debug as well. So let's go with this one. It seems to work. So should be good. Okay, then we remove this. And we remove that. All of this shit here. There we go. And then here we do this. And here we remove all of this. There we go. Get inverse. Cool. Okay. Let me ask chat to generate me some comments. That works. Can you generate some comments? Some code comments for inverse to explain what it does mathematically. Details. Oh my gosh. Matrix inverse. Then here let's add these comments here. Saying uses a color major, blah, matches. We have this. Okay. Step 3. Compute determinants of 4x4 matrix. Step 2. Step 1. Step 4. Educate. I have no idea what that means. Educate. Okay. Column J. Step 1. Read matrix elements into local variables. Okay, cool. Can you, if you want, I can also create a short diagram inside the comments showing how maps in the 4x4 grid. Hours of confusion. Yeah, show me. Yes. Show me. Oh boy. Okay, it's a bit too much. Maybe we can put this comment down here at the top somewhere. Matrix4x4. Let's put it here. Maybe, no, let's put it here. Matrix layout convention. Memory layout. Okay, I have no idea what this says, but looks good. Let's take that. Let's also fix this here where we added, yeah, we are generous. Okay. Well, maybe that's a bit too much. Okay. Maybe we put this comment above the class. Can you generate the same comments for the same kind of comments for the Matrix 3D? Last row, yes, we can write. Okay, let's copy this here. Let's go to Matrix 3D. Row 3 implicitly. So directs what what major and vector do direct X matrices does the direct X matrix use? Row or column? Column major with column vectors, but that can't be true, right? Row column. Columns are contiguous in memory if using matrix or row float array. So memory is technically a row major in C++, but the mass assumes column major. Technically a row major. Column vectors. If you store matrices format in your own engine, you have to transpose when passing to DirectX. If your internal convention is row major. Is it now hallucinating? DirectX matrix. Row. Affine transformation. Row major. DirectX offers both left-handed and right-handed versions of matrix functions with handedness, but always assumes a row major format. Okay, I mean, according to Microsoft's documentation, DirectX matrix is row major. Yes, classic source of confusion. Microsoft's row major documentation says row major, but matrix because the C++ memory layout is row by row. In memory, it's a row major memory, column vector mass. Despite the row major storage, all DirectX mass assumes column vectors. What? So you multiply a vector on the right. Transformations like matrix translation produce matrices that assume column vectors. Row major versus column major can mean two things: memory layout, multiplication convention. Row major, memory layout, column vector. They mean memory layout, not multiplication convention. To me, it looks like the AI just wants to be right. It always assumes row major format. They mean memory layout, not multiplication convention. You do not need to transpose your column major engine smart if you match convention. They appear transposed visually unless you account for the memory layout. That's why some old Westwood code mentions transposed. You do not need to transpose your column major engine matrices. column major into matrices if you match. Okay. Okay. Post multiplied. Okay, this layout. I'm not so sure about these comments here. Okay, so here we have compute subdeterminants, minors, cofactor expansion. Okay. Okay. That's the compute. Right. Multiplies. This one seems to be useless. Okay, does that make sense? Well, compute. Linear and translation elements. Okay. Does that make sense? Yeah. Then history 0301 2026. Spikers. Implemented with ChatGPT. Assistance of ChatGPT. Then we do the same here. Okay. Okay, well, the result seems to be correct now, so that's good. Still not sure about this comment here. Maybe we just don't add this comment. Let's remove it again. Major. We can figure out a better and a separate change. Okay. Okay. Matrix. Okay, cool. Okay. Now the question is, did we miss anything? Possibly. set matrix identity. Okay, we still need to remove this here. Let's do that. Note that DX transform function take the matrix in DX8 format. Then we can also remove these guys here. There we go. So DX8 transform 0, 0. Maybe here we can use the 0, 0 style. Does that exist? DX matrix. Just underscore. But it takes 1, 1. No, then I won't touch it. Let's leave it like that. Okay, cool. Cool. That looks all correct to me. Here we have a mem set 0, which should be fine. Okay. Tree buffer. Okay. Cool. Okay, I think that's all I can say about this. Let's run the game a bit and see if we run into any more issues. Now the question is, do we need to worry about world builder in any way? Probably not. Probably not. World builder should be fine. Yeah, it just needs to be replicated to generals then. But most of the stuff is already in core, so that is good. Yeah. Okay, well, it's not much here in 0 hour. Matrix4x4. Okay. Good. Let's run the game a bit and see if there are any leftover issues. Good. So the board looks normal, the water looks normal, particle effects look good, shadows look normal, infantry looks normal, vehicles look normal, terrain looks normal, trees look normal, threads look normal, lights we can see. Let's make it a bit faster. Vehicles look normal. Yeah. Okay. Okay, that looks all good to me. Let's load some mission here. Career losses 122. Oof, big loser. Damn. Okay, let's build here some. Let's load the test map with all the units. Okay, let's put an enemy. USA. Good. Then let's attack here. Attack here. Okay, it's attacking. Bomb truck. It's not driving. Let's micromanage him. Yeah. Toxin tractor, very efficient. So. Mm. 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 Okay, the game works. Let's rotate the camera a bit, yeah. Let's zoom in and zoom out, yeah. Let's click on the radar, works. Yep. I think things are working. The game works. Mm-hmm. Fantastic. Then I think this change is done. Mm-hmm. Now there's one more question here. So in Matrix 4, we added here functions to convert DirectX matrix to Matrix4x4, but we don't have an equivalent here. But we don't have an equivalent for Matrix3D. Is that a problem? Well, we don't use it. So this one is used a few times. Yeah. Matrix4x4 else. Get transform world. Yeah. Okay, so it's just used 3 times. That's it. Yeah. Get transform. Yeah. Make identity. Get wrapper.h. Wrapper.h. So transform. Where's get transform? Here. Okay, I think that's fine. Okay, then we create a new branch and call that refactor matrix C casts. Okay. Then to a refactor math. Let me see. Open author Baptista. This one, unsafe cars with proper transpose conversion. DX8. DX8, yeah. I think DX8 is a reasonable factor. DX8. Just do math. Math is also okay. Replace. Remove C casts. Remove. Let's say properly implement matrix 4x4 inverse matrix 3D get inverse eliminate replace D3D matrix replace unsafe matrix 2 or yeah unsafe matrix 4x4 to casts replace and replace unsafe casts with help of with conversion functions that apply the required transpose. Okay, that's it. Good. Then let's push this guy. Push. Good. Yeah, the problem is, so the reason I redid this now, I don't think it would have taken many review iterations to get this guy properly fixed up, in my opinion. Like I would have needed to re-review and re-review all the time, and it just would go on forever. I don't know what the good solution is. Like, yeah, like the more complex the change is, the more careful we need to be to do it correctly, right? If a change is simple, then it's easier to get it right. But then if it's more complex, then there needs to be even more diligence. And the problem with AI-generated code is that it's not diligent, right? It just generates the answer from noise, right? It just tries to predict the most correct answer, and yeah, the human still needs to figure out if the prediction is correct. The advantage of AI is that it can predict a lot of stuff in really short time, right? So it can like generate a lot of complex things and throw at you, and then you can work with that. But it's not accurate, right? So it has a lot of errors, inaccuracies, mistakes, and all these things, and you need to sift through and correct anything that does wrong. And it also it generates it in ways that fits a prompt, but doesn't necessarily fit the way you actually want to have it in the end, right? So you either would need to fine-tune the prompt to get exactly the result you want, or you need to fine-tune the result that the AI generated for you. And so then what happens is you just keep iterating on what the AI gave you over and over again. And that just takes forever, because then the reviewer has a burden of correcting all the things that the AI has generated or that the original author has put there, right? So it really adds a huge burden on the review process. And so sometimes for me, it's just easier to make the change myself and just get it done instead of getting stuck in this review process, because the review process will steal a lot of time. Like I can't work on things and test things if I'm stuck in the review process all the time. And it's possible to AI generate infinite amount of code. Like we can populate 1,000 pull requests now, 1 million pull requests, like we won't be able to review all this and verify correctness, right? We can just infinitely generate things, but there's no way to, for a human, there's no way to verify correctness. So the only way to do this would be either to have like AI reviews for all AI generated changes, but then the AI review would have the same limitations than the AI code generator, right? In the end. Or there's more human craftsmanship in the whole creation process, and like getting like an absolute correct result, which there's no way that this can be improved any further than what is presented in the review. Like if the review is perfect to begin with, then the review process will be swift, right? Like there's nothing to correct. It's just perfect code. Go ahead, right? Obviously, it's hard to like get everything perfect, but I would say it's possible to identify changes which are high quality and which are not so high quality. And I would say the AI generated stuff it's quite a strain. Yeah. Good. So I generated this pull request and I put it here. Then let's put this here. Say implement inverse. Good. Reviewers, I will put Baptista here. Labels, refactor, major rendering. Okay. Okay, and so this one is similar to what he did here. So it will fix this one, fixes this, oh boy, fixes this, and we'll close this change. Fixes, closes this. To do applicate in generals, and this change implements inverse and get inverse, so that we do not need to use D3DX. D3DX. Is that correct? Let me search D3DX matrix inverse. Was that the name? Yeah. We do not need to use for it. Anymore. There are 4 callers. Eliminates all C casts between D3D matrix D3D matrix, D3DX matrix, and Matrix4x4 or unsafe C Matrix3D. New helper functions. The following new helper functions help converting between them with transpose, just like the original did. Following between the matrices. So that is Matrix4x4 for okay. So these yeah, I think yeah, we take the whole Matrix3D. Okay. Let's pay. There we go. Verified to produce same results. Save cast that I was able to find. Fixes this, parameter transpose. We do not need to use matrix inverse for Matrix4x4 and Matrix3D. Anymore. Following new helper functions help converting between the matrices. Implement matrix. Okay, I think that works. 495 additions, 297 deletions. Maybe we can improve this text here. Convert matrix. Vice versa with the conversion functions below. Always converts below. Copying one matrix to another. Therefore, copying one matrix on will always require transpose. Always convert Matrix3D, or vice versa with a conversion function below. Reason being, D3DMATRIX is row major. Is row major, is column major. Column major. Copying one matrix to the other, one matrix. Copying one matrix to the other will always require transpose. I like this description better. Okay, I would say we put this here as well. There we go. Good. Let's push this. Push. Okay. ChatGPT was used to help implement textbook implementations. The textbook math. Okay. I suspect that generals will fail to compile with this change. Maybe, or maybe not. Let's see. Yes, storing D3DMATRIX in render state structs makes sense. I re-implemented this change with re-implemented this change from scratch because I was not happy with the implementation details of this change. I was not entirely happy with. Okay, so this one fails to compile already in generals. Yeah, okay, but if generals fails, I think that is okay, because it still needs to be replicated, right? Cannot convert. Yeah, that's fine. Generals will fail to compile until replicated. We need to say here get inverse with capital. Good. Good. What's the time? 4 hours 30. Jesus. Time flies so fast when working on this math stuff and fighting with ChatGPT. Yeah. Trying to figure out how to get the right math there. Yeah. Okay. One new notification. Camera edge scroll broken after loading a save game from in-game menu. Edge scroll broken. Right there. Many seconds later. Okay, this one we need to revisit. Yeah, I can do it next session. So let me close this. So this one was approved, okay. This one still needs a push. change or edit was not pushed. Good. Then I think it's time for a break here. Has been 4 hours 30, really long session again. The last session already was almost 5 hours, 4 hours 50. Now another 4 hours 30. Oh boy, long sessions. Yeah, good. Probably will take a few hours break now to eat and maybe move a bit. Yeah, move the body. Good. Then I wish you a great day or night until next time. Goodbye.